Okay, class, today we're going to start talking about real numbers and their properties. This is under the review section R2. And so last time we talked about sets and their properties in relation to other sets, and today we're going to talk about a particular set, the real numbers. And so these are what we're going to talk about today. Okay, so the set of numbers and the real number line. Um, As mentioned previously, the set of natural numbers are written as follows. Okay. Now, if we add the 0 to the set, we add a 0, right? So we add that, that's going to call the whole numbers. So the whole numbers are the natural numbers plus 0. And then we have the negative numbers that we're also including here for the integers. So we'll talk about that too. Um, So if we take the whole numbers, the set of whole numbers, and add the negative values of the natural numbers, this is going to give us the set of all integers. Now, integers can be graphed on the number line. As you can see over here, the origin is at 0, and you can see that each of the dots represents where an integer is located on the number line. Okay. The number associated with the given point is the coordinate of the point. So where the location is given on the number line by what we call a coordinate. Okay, so this course forms a coordinate system on the real number line. Okay, the result of dividing two integers with a non-zero divisor is called a rational number. So these are where we get our fractions from. So if we divide all these numbers by 1, we get the same numbers, but we can divide these numbers by any other value other than 0 as well, and we can get all the fractions, and that's where we get the rational numbers. And the rational numbers are defined by using the set notation given as follows. P divided by Q such that P and Q are both integers, where Q, the denominator, is not equal to 0. Okay, and so if we do that, then we get all of these values because we can represent any fraction on the number line. Okay, so the set of rational numbers includes the natural numbers, the whole numbers, and the integers. And so for the integer -3 is a rational number because it can be written as -3/1. So all integers are also rational numbers. Okay, numbers that can be written as a repeating or terminating decimal are also rational numbers because they can be represented as a fraction as well. Okay, so the set of all numbers that correspond to a point on the number line are called real numbers. Okay. Oops. Okay, so real numbers can be represented as decimals because every fraction has a decimal form. Okay, for example, 1/4 is equal to 0.25. Okay, real numbers include the rational numbers. Okay, so think about a set inside of another set. Okay, some real numbers cannot be represented as by quotients of integers. Okay, these are called the irrational numbers. Okay, so irrational numbers are another set of numbers that are outside rational numbers. And if we put both of these sets together, it gives us the real numbers. Okay. Um, so for example, negative square root of 2 and the square root of 5 are irrational numbers. Pi is an irrational number as well. Okay. So if we look at sets of numbers, we have the natural numbers, and the natural numbers fit inside are a subset of the whole numbers, and whole numbers are a subset of the integers, and integers are a subset of the rational numbers. Okay, and then we have the irrational numbers, which are which is real but not rational. Okay, and then if we take the rational numbers and the irrational numbers and put them together, we get the real numbers. Okay, so here's an example. So we're going to let a equal this set of numbers, and we want to list all of the elements of a that belong to each of these sets. So the natural numbers. So which one of these numbers are part of the natural numbers? Well, it's going to be all of the positive integers bigger than 0. So this is 1, and 6 is also another one. So 1 and 6 are going to be part of the natural numbers. Then if we go to the whole numbers, then we're going to add 0 to the mix. So it'll be 0, 1, and 6. And then if we talk about C as integers, if we locate all the integers, well, that's going to include the negative values of whole numbers. Okay, so or natural numbers. So we got -8, -6, 0, 1, and 6 are then included in that set. And then we've got the rational numbers. Well, the rational numbers are going to include all the numbers that I just mentioned, and then the fractions. So it's going to include this one, this one, this one, this one. Okay, in fact, everything except square root of 2 and the square root of 5. Okay, and then the irrational numbers are just going to be the square root of 2 and the square root of 5. And then the real numbers is going to be the whole set A, because all of the numbers in set A are real numbers. Okay, so here's a picture of how to visualize it. Okay, so we've got the natural numbers, and then from there we've got the whole numbers, and then outside of that we got the integers, the rational numbers, and then we've got this distinct set over here of irrational numbers. And if we put the rational and irrational numbers together, that gives us the real numbers, the set of all real numbers. Okay. Okay. Now, exponents. Any collection of numbers or variables joined by the basic operations of addition, subtraction, multiplication, or division, except by 0, are the operations of raising to powers or taking roots. Formed according to the rules of algebra is an algebraic expression. Okay, so let me repeat that. Any collection of numbers or variables joined by the basic operations of addition, subtraction, multiplication, or division, or the operation of powers or roots, forms what's called algebraic expressions. So all of these examples down here are what we call an algebraic expression, because they're letters and numbers that are put together by one or more of those operations. The expression 2 to the third is an exponential expression, or exponential, where the 3 indicates the 3 factors of 2 appear in the corresponding product. So 3 here as an exponent means that 2 is a factor 3 times. Okay, so the base is called 2, so the base is the 2, and the 3 is called an exponent. So again, by definition, 3 to the third power is 2 times 2 times 2, which equals 8, because we're saying that there are 3 factors of 2. So exponential notation. If n is any positive integer and a is any real number, then the nth power of a is written using exponential notation as follows. So this is exponential notation, a to the n, which means we're going to multiply a n times, or we're going to have n factors of a. Okay? So we want to evaluate the following expressions and identify the base and the exponent. So here the base is 4, the exponent is 3, so this means that we're multiplying 4 3 times. So we have 3 factors of 4, so 4 times 4 times 4, which is going to give us 64. Okay, and then -6 quantity squared. Now this negative sign is inside the parentheses, so very important to remember this. We're taking -6 and raising it to the power of 2. So this is -6 times -6, which is a positive 36. Now if we look at C, though, there are no parentheses. And the negative sign is there, which means the negative sign is not included in the power. So this is not the same as b. This is 6 times 6, and then we're taking the negative value of this product. Okay, so the negative sign is outside the square. So this is 6 times 6, and then we're going to take the negative of the result. So this would be negative 36. And then this here, we're taking 3 squared and then multiplying by 4. So this is 4 times 3 times 3, okay, which is going to be 9 times 4, which is positive 36. Here, the parentheses, we've got to consider the parentheses. So everything inside the parentheses is being squared. So this is the quantity 4 times 3 squared. So that means we're going to do 4 times 3, and then we're going to do times 4 times 3. So it's going to be 4 times 3 times 4 times 3, which is going to be 16 times 9, okay? Which is going to give us 144, or 12 squared, which is 144. So either way, okay? So remember, the parentheses, we can simplify inside the parentheses. Remember the order of operations. So we could use the definition of powers, or do what's inside the parentheses first, which would give us 12, and then 12 squared is 144. Okay? Okay, so the order of operations. Okay, when an expression involves more than one operation symbol, such as this expression, 5 times 2 plus 3, which do we do first? Well, we have to follow the order of operations to make sure that we get the correct answer. Okay, so the order of operations says this: if grouping symbols such as parentheses, square brackets, absolute value bars, or fraction bars are present, begin as follows. 1. Work separately above and below each fraction bar. So if we're looking at a fractional expression, we do the top and the bottom separately. Okay. 2. Use the rules below within each of the parentheses or square brackets. Start with the innermost set and work out. So if we have multiple parentheses, we'll always work from the inside parentheses to the outermost parentheses. Okay. If no grouping symbols are present, then we use the following symbols. We do all powers and roots from left to right. 2. We do multiplication or division in order from left to right. And then any negations, additions, subtractions in order from left to right. Okay, so now here's an example where we want to use order of operations to solve this example. So part A. So again, always think of PEMDAS. P-E-M as in Mary, D as in David, A as in Apple, S as in Sam. PEMDAS. The order of operations is always parentheses, exponents, multiplication and division. Again, remember left to right. And then adding and subtracting left to right. Okay, so in this case here, we've got division, addition, powers, and multiplication. So we're going to do the exponent first. So this is going to be 8. And then after that, we're going to do division and multiplication left to right. So we're going to do this division first, which would be 2. And then we're going to do this division next, or this multiplication next, which would be 5 times 8, which is 40. So in this case here, we get 2 plus 40. And so then we end up with 2 plus 40, which is 42. Okay, and so that's the correct answer. Okay. B. Well, here we've got adding, division, multiplication, subtraction, and we got parentheses. So do the parentheses first. Okay, so we're going to get 14 here. And then we're going to do multiplication, division, left to right. So we're going to do the division first in this case. So we're going to get 14 divided by 7, which is 2. And then we're going to do the multiplication. So 2 times 3 is 6. And then 6 minus 6 is 0. So the answer is 0. And then here we've got a rational expression. So we're going to do the top and the bottom separately. So here we're going to do the 3 squared first, which is 9. Then we're going to do the addition, which is going to give us 13. Then we're going to go to the bottom. We're going to do the multiplication first, which is going to give us 15. And then we're going to do 6 minus 15, which is going to give us negative 9. Okay? And then what do we have? We've got 13 over negative 9. So we get negative 13 ninths. Okay? And I think that's where we're going to leave it at. Yep. So we're going to leave it in simplified form. And so now we're going to do the same thing here. So now, okay, so what do we got? We've got, we're going to do the top first. So we've got negative 3 cubed. So this is negative 3 times negative 3 times negative 3, which is going to give us a negative 27. Okay? But we're going to take the negative of that. Okay, so that's going to give us positive 27. So then we're going to do positive 27 plus a negative 5, which gives us a positive 22. Okay, so we got a positive 22 on the numerator. Now we go to the bottom. Okay, so we're going to do the multiplications first. So we get negative 16 minus 15. Okay, so negative 16 minus 15 is going to be a negative 31. Okay, so we've got a 22 over negative 31. Okay. Now we're going to evaluate the expression for x equals negative 2, y equals 5, and z equals negative 3. So what we're going to do is we're going to plug and check. Okay, so we're going to plug in these values for x, y, and z, and then we're going to solve. Okay, so x is negative 2. So in this case here, x is going to be negative 2 squared. So it's negative 2 quantity squared. So it's negative 2 times negative 2, which is going to give us positive 4. And then negative 4 times a positive 4 is negative 16. Okay. Y here is 5, so we're going to get what? We get 5 times 3 is 35, so we're going to get 35 here. Okay. So we're going to end up with what? A negative 16 minus 35. And then we're going to get z, which is negative 3. So we get 4 times negative 3, which is a negative 12. So we're going to get a minus 12. And so we subtract all of these and we get negative 36. Okay. And then likewise, we're going to do the same thing. So what we're going to do is we're going to plug in the values for each one of these into x, y, and z. And then we're going to use the order of operations to solve. Okay. For both of these. Okay, so again, these are rational expressions, so we're going to do the top and the bottom separately, right? The numerator and the denominator separately, and then plug and chug. Okay, so if we look at this, that's exactly what we're going to do. So we plug in the values, right? Negative 2, 5, and negative 3. And then we're going to use our order of operations to solve. So this negative 2 minus 5 gives negative 7, so it becomes a negative 7 squared. This becomes, again, just 4 times 5, and this becomes negative 3 plus 4. Okay, now we're going to use the exponents. We're going to solve the exponents. This is going to give us 49. Okay, now we're going to do multiplication. So the multiplication here gives us 98. This multiplication here gives us 20. And this addition here gives us a negative, excuse me, oh, hold on a second here. Yeah, this gives us a positive 1. And so obviously we can get rid of the fraction because this added divided by 1 is going to be the same thing, so it's going to be 118. Okay. Now, in this complex fraction here, we're going to work separately in the top and the bottom. Okay. But we've got fractions here. Okay. So we're going to treat these top and the bottom separately, and then we're going to divide as the last step. Okay, so now if we plug in the x, y, and z, we get this. Okay, so this gives us -1, and this gives us 1. So we're going to get a -1 minus 1, which is -2. Okay, and then the top, this is going to give us a -9 over 9. This is going to give us a 15 over 5, which is going to give us a 3. Or excuse me, I'm sorry, 40 over 5. Okay, which is going to give us an 8. Okay, because 5 divided by 5 is 1. So we're going to get an 8. So either way you do it, you're going to get the same value. You're going to end up with 8. And so we get -1 plus 8, which gives us 7. And so we get a -2/7 as our final answer. And so now we're going to look at the properties of real numbers. So whenever you look at the order of operations and you see the properties that are going on, these are the properties that are going to be for all real numbers. Anytime you're dealing with real numbers, these are the properties you can rely on. Okay, so we're going to let A, B, and C represent real numbers. So the closure property basically says this: if we add two real numbers, we're going to end up getting a real number. So no matter how many real numbers you add, the result will always be another real number. Same thing goes with multiplication. Multiplication also has the closure property. So a closure property works for both addition and multiplication. In other words, whenever you multiply two real numbers, the result is going to be another real number. Okay? So you can never get anything other than a real number. That's what it means to be closed under the operation of addition and multiplication. Commutative properties. That means the order doesn't matter. So the commutative property works for both addition and multiplication. It means that it doesn't matter the order in which you add or multiply real numbers, you'll get the same result. The associative property, okay, this is less to do with order and to do with what you're going to do first. Okay, so this deals with moving parentheses around. Okay, the associative property also works for both addition and multiplication. So if you have three numbers and it doesn't matter whether you add these two first or whether you add these two first, you're going to end up with the same result on both sides of the equal sign. And the same thing goes with the multiplication. So it doesn't matter if I multiply the A and the B first, or if I multiply the B and the C first, I'm going to end up getting the same result when I multiply the 3. Okay, the identity properties. Okay, so there's an identity for addition and subtraction, or excuse me, for multiplication. This means that there has to exist a number that I can add any other real number to, and it will leave the real number unchanged. That identity, which we call the additive identity, is 0. And also, there has to be an identity for multiplication, which means that there has to be some real number that I can multiply any other real number by, and I get the same. The operation leaves the real number unchanged. And so the multiplicative identity is 1. Okay? Now, inverse properties. How do inverse properties work? Well, there has to be what we call an inverse, an additive inverse, and a multiplicative inverse. So when we're talking about addition, if there exists a number such that we can add another number to it and we get the identity, the additive identity, that's the inverse. So in addition, it's the negative values. Okay? So the negative value is the inverse of the positive value. Okay? Or the positive value is the inverse of the negative value. So if we have some number A, well, if we add the opposite of A, we're going to get 0. So the opposite of A, or negative A, is the inverse, the additive inverse. Okay? Again, if A is not equal to 0, then we also have a unique A that exists in which we can take the multiplicative inverse and get the multiplicative identity. So if we take any real number a other than 0, we can take the inverse of that, the multiplicative inverse, which means we're going to take 1 over that number. If we multiply those two numbers together, we get 1. Okay? And it doesn't matter on which side you multiply by, just like it doesn't matter which way you add. Okay? So you'll get 1. So these are the inverse properties. Now the multiplicative inverse, or excuse me, the distributive properties. So the distributive property works for both addition and subtraction. Okay? Now, the distributive property for addition means that we can distribute the a across across addition or across subtraction. So that means we can distribute the a to the b and the c, and we can get a times b plus a times c. And the distributive property says that both sides of the equal sign will be the same. And the same goes for using it across subtraction. Okay? Now, the multiplication property of 0. This property says that 0 times any real number will always give us 0. Okay? So a times 0 equals 0 times a equals 0. This is what we call the multiplication property of 0. Okay? Now, caution. With the commutative property, the order changes, but with the associative property, the groupings change. So again, remember the difference. Commutative. Think about commute. When you commute to work, you are moving to work. So numbers are moving. Okay? The associative property is that it's not the order that's moving, but it's the parentheses that are moving. Okay? So let's look at some examples of simplifying expressions. Okay. So let's look at this example. So we're going to use the commutative and associative property to simplify these expressions. So the first thing I'm going to do is I'm going to use the associative property. So I'm going to move the parentheses over here and add these first. Okay? Because I can't add the x and the 9, but I can add the 6 and the 9. So I'm going to use the associative property to group these together first to get 15, and we get 15 plus x. Okay? Now here, I've got 5/8 times this quantity. So again, I'm going to use the associative property and group the 5/8 with the 16 and multiply those first. Okay? And then I can take 16 divided by 8 and get 2, and I'll get 2 times 5 is 10, and I get 10y. So again, I can use the associative property and just decide, hey, instead of multiplying these two first, I can multiply these two first. Now here, I'm going to use the commutative property to get these two together because, again, I can't multiply by p, but if I move these around and put the 6/5 next to the negative 10, then I can go ahead and simplify. So in this case, I'm going to use the commutative property, and I'm going to get negative 12p. Okay, now in this figure here, this helps to explain the distributive property. Okay, think about this. I'm taking this big square, this big rectangle, right? And so I can either take this height of the rectangle times the sum of the two bases to get the area, right? So I can do 4 times 15, or excuse me, 4 times 8. So 4 times 8 is going to give me what? 32. And so the area is 32 square units. Or I can use the distributive property and say, okay, well, I can get the area of this small one and the area of this small one because this height is still the same at 4. So then I could take the area of these two smaller rectangles and add them together. So I could take 4 times 3 is 12, plus 4 times 5, which is 20. And if I take the 20 plus 12, I get the same 32. So this is a visual of helping us to understand why the distributive property works. Now, it says rewrite each expression using the distributive property and then simplify if possible. So here we're going to use the distributive property and write this as 3x plus 3y, and we're done. Can't be simplified any further. Here I'm going to use the distributive property to distribute the negative sign. Now this is like -1. So this -1 I'm going to distribute across the subtraction, and it's going to be like -1 times m, which gives me -m, and then I'm going to do a -1 times 4 times n, okay, which is what they're doing here. And so you get a -m plus what? Plus 4n, okay? And now here, this distributive property, now notice we're going to use the distributive property of factor. So this is calling factor. We're going to pull out a common factor. Well, we can do that because of the distributive property. So the greatest common factor here that comes out of both of these is 7, because 7 is a factor of 21, and it's also obviously a factor here. So we can pull the 7 out using the distributive property, and we get 7 times the quantity p plus 3. Okay, and now this here, we're going to use the distributive property to simplify this by distributing the 1/3. So see what we're doing here? We're going to distribute the 1/3 to each one of these terms as such, and then we're going to simplify each term. So here we get 4/15 m minus, because we got a negative sign, so it'll be minus 1/2 n, and then we're going to have minus what? This is going to be a minus 9. And so we get this, and there's nothing else we can do to simplify this. Okay, now, on the order of the number line, okay, if the real number a is to the left of the real number b, then what we say is a is less than b. So where your position is on the number line is important. If you are to the left of another number, you are less than that number. If you are to the right, then you are greater than. So if a is to the left of b, then a is less than b. If a is to the right of b on the number line, then a is greater than b. Okay? And this is based on the number line, okay, what we know about real numbers. Okay, so now, statements involving these symbols as well as the symbols of less than or equal to and greater than or equal to are called inequalities. Okay, the inequality a is less than b is less than c means that b is between a and c, because a is less than b and b is less than c. Okay, see how that works? Now, absolute value. If we don't care about the direction, okay, and all we care about is how far a value is from 0, as far as distance, how many units, let's say, we don't care about the direction, but we care, hey, how many units a particular value is from 0, that's called absolute value. Okay, it's the undirected distance on the number line from a number to 0. That's the absolute value of a number. Okay, so if we want the absolute value of 5, Well, how many units is 5 from 0? And the answer is 5. And if we want the absolute value of negative 5, again, how many units away from 0 is negative 5? Well, the answer is 5. So the absolute value of a number is always the positive value of that number. Okay? Now, because distance cannot be negative, the absolute value is always positive or 0. So here is the definition of the absolute value algebraically. Okay, so the absolute value is equal to a if a is greater than or equal to 0, but the absolute value of a is equal to the negative value of a if a is less than 0. Okay, that is, the absolute value of a positive number or 0 will always equal that number, while the absolute value of a negative number is going to be the opposite of that value. So it will always be positive. So in other words, the absolute value of negative 5/8 will just be 5/8. The negative of the absolute value of 8, though, be careful, the absolute value of 8 is 8, but the negative value then is going to be negative 8. Okay, so the negative sign is outside the absolute value. Okay, here, this we're going to handle inside. So this is the absolute value of negative 2 is just positive 2. But then the negative value of that is going to be negative 2. So this is going to end up being negative 2. Here, the absolute value of the absolute value of 2x for x equal to pi is going to be the absolute value of 2 pi, which is just going to be 2 pi, because pi is positive. Okay. Okay, so absolute value is useful in applications where only the size, or what we call magnitude, is important, not the sign. Okay? Okay, so here's example number 8. Systolic blood pressure is the maximum pressure produced by each heartbeat. Both low blood pressure and high blood pressure may be the cause of medical concern. Therefore, healthcare professionals are interested in a patient's pressure difference from normal, or what we call P sub D. If 120 is considered a normal systolic pressure, then the difference P sub D is the absolute value of P, your blood pressure, minus 120. Okay, where P is the patient's recorded systolic pressure. So find the pressure difference for a patient with a systolic pressure P of 113. So all we do is plug and chug. So we're going to put 113 in here. So 113 minus 20 is going to be negative 7. So the absolute value of negative 7 is going to be positive 7. So the pressure difference is going to be 7. Okay, so here are some properties of absolute value. So these are going to be very important for you to remember. This comes up all the time in this class. The absolute value of A obviously will always be non-zero. Okay, the absolute value of negative A is equal to the absolute value of A. That's also obvious from what we just talked about. 3, if we take the absolute value of A times the absolute value of B, well, that's going to be the same as the absolute value of the product A times B. Okay? Because again, if it doesn't matter if A is positive or negative, it's going to be the same. It's going to be positive. And if it doesn't matter whether B is positive or negative, it's going to be negative. Well, it doesn't matter if the product of those two are going to be negative or positive. It's always going to be positive. Okay, now, this one here, 4, says if we take the quotient of two absolute values, it's going to be the same as the quotient, the absolute value of the quotient. So the quotient of absolute values is the same as the absolute value of the quotient, as long as b is not equal to 0, of course. And 3, you could say, says that, hey, the absolute value of the product or excuse me, the product of the absolute values is the same as the absolute value of the products. Now, the triangle inequality is something you will have to remember. Okay? It's not equal to, but it's less than or equal to. If we take the sum, right, the absolute value of the sum of two numbers, two real numbers, okay, that is not going to be necessarily equal to the sum of the absolute values. It's actually going to be less than or equal to, okay? And so here are some of the examples of the properties. Okay, so again, pay attention to these and look at, make sure you know as far as the triangle inequality here. Okay? Okay, so now let's look at example number 9. Evaluate the absolute value of the expressions. The absolute value expressions. So let x be equal to -6, y equal to 10. So we're going to plug in -6 and 10 into these. So this is going to be -6 times 2, which is going to give us a -12, minus 3 times 10, which is 30. So what do we get? We get a -12 minus 30, which gives us a -42. The absolute value of a -42 is +42. So we get +42. B, we're going to get -6. So -6, the absolute value of -6 is +6. 2 times +6 is 12. Then we get 3 times 10 is 30, but the absolute value of 30 is still 30, minus 30. So we get what? We get 12 minus 30, which gives us a negative what? A negative 18, right? Now here we get -6 times 10, which is -60, which gives us +60, okay? And so what do we get? We got, what do we got on the top? We got -18 over 60, which gives us a -3/10. Okay, so now let's look at distance between points on the number line. Okay, so let's take a look at this. Okay, if P and Q are points on a number line with coordinates A and B, respectively, then the distance PQ, right? So the distance between P and Q is nothing but the difference between B and A, or the absolute value of A minus B. So order doesn't matter, right? So it's either way, it's going to be the same. So we take the absolute value of A minus B or B minus A, you're going to get the same number. Okay? So if you take the absolute value, then you don't have to worry about the order. Okay? But if they're on the number line, obviously you're going to take the bigger number minus the smaller number. But if you have the absolute values, it doesn't matter, because we're talking about distance. Okay? And distance is always positive. Okay. So find the distance between -5 and 8. Well, obviously we could just subtract these two, right? Take the bigger number minus the smaller number and we get 13. But if we use the formula, we know it's going to be the absolute value of B minus A or the absolute value of A minus B. It doesn't matter. Okay? So if we do the absolute value, if we take these two numbers, subtract them, and take the absolute value, then it doesn't matter. We're always going to get the same number, which is 13. Okay? Again, B minus A minus B, you get the same number. Okay? And that finishes up this video on the real numbers and their properties. Again, make sure you practice these, ask questions in class, and I will see you next time.